Hello, my name is Darren Thomas and I am the Director of Educational Research Techniques. In this video, we're going to take a look at double angle formulas for exact values. So let's go ahead and talk about this a little bit. Now, in the past, we've been looking at sum and difference formulas for sine, cosine, and tangent. And in those situations, I'm just going to do a quick review here because otherwise this might not make sense. You had the following formula, sine A plus alpha plus beta basically equals sine of alpha times cosine of beta plus cosine of alpha times sine of beta. And there is also a caveat that if there's a minus sign here, it would be a difference, and so there'd be a minus sign over here as well. So it just depended on the situation. Now, here's the thing. When we were using this, we were using special angles from the unit circle, special angles for alpha and beta right here, you know, like pi over 3 or pi over 4, etc. You can look at the previous videos on that. Then we were using that to try to find out what was going to happen over here, if you will, because we were trying to find the exact value right here. That's what we were trying to figure out. And we were using the different special angles to try to calculate the appropriate exact value that we wanted. That's what we were doing. Now, when we're dealing with double angle exact formulas, here's what's happening. We are now going to assume the following. This is what's happening. Alpha equals beta, and of course it also equals theta when you have the angle. And so now the values that are inside the parentheses here are going to be the same. And since they're the same, they're just doubled, you know, okay, because it's 2a now. Instead of a plus b is just 2a because the value a and the value b are the same, so you don't need a b. Just have an a, and you call it a 2a or a 2b or whatever you want to call it. That's basically what's happening now. And so in this kind of a situation, things are different. Now, one other thing I need to mention is that the primary purpose of, I don't say the primary purpose, but one of the purposes for figuring out the double angle formula for finding exact values is that you want to like cut an angle in half, or if you want to double an angle or whatever. So the example I've seen in some textbooks is like, you know, you have a ramp, something like this, and you want to cut this value right here in half, or you want to double it. You might want to use the double angle formula for finding the exact values, and that's kind of one of the purposes that I know that they can be used for in terms of a real applicable application. Now, having said that, we need to look at the different formulas that can be used for the double angle formula for finding exact values. So here they are, and again, you can kind of prove these on your own time. But you know, we have sine. When you want to figure out what the sine value is, it's going to be sine 2 theta. Remember, why is it 2 theta? Because a and b are the same. That's kind of why it is like that. And it'll equal 2 sine theta multiplied by cosine theta. That's for finding sine. If you want to deal with cosine, you have the following. Oh, let me put that in a different color. You have the following. If you want to deal with cosine, it's 2 theta again. And then let's see here. You have cosine squared theta minus sine squared theta. And then for tangent, just do another color here. Tangent, of course, is going to be 2 theta again, equals 2 tangent theta, like so, over 1 minus tangent theta, tangent squared theta. So these should all look familiar. They're kind of like what we did in the past, but they're slightly different because we have the same a and b here. That's what happens. And so this is going to make more sense with an actual example, but we're going to keep coming back to this screen because we're going to build off of it. So here's our question that we're trying to figure out. And there's a lot of things that we have to do all at the same time, and this is where things kind of get complicated. So we have the value tangent theta equals 3 over 4, negative 3 over 4 by the way, and it's inside quadrant 2 of the units, quadrant 2 of what do they call it? The Cartesian plane, if you will, Cartesian graph. All right. And so now what we need to do now is we need to calculate the following double values here. Calculate. we want to figure out, let's see here, sine, put a different color. We're going to figure out sine of 2 theta. We want to figure out cosine of 2 theta. And we want to figure out tangent of 2 theta. So essentially what we're going to do here is we're going to use each of these formulas on this prior screen, plug in the appropriate numbers. Now, what we need to do now is that we need to visualize this. That'll be the first step we need to do. So we know that we are in the second quadrant. Okay, so this is quadrant number 2 right here. Okay, and so we have the tangent values, and so the tangent values kind of tell you the cosine and the sine and the cosine values. So rise over run. So very, very simple. So that means we're going to go to the left 4 because it's negative 4. And we're going to go up 3. That's what we're doing here. So we're just taking these values up here because, as you know, the tangent function is a ratio of the cosine and the sine function. So we do that, and so we draw our triangle like so, up to 3, all the way down like that. And so this distance right here, I already put it, but it's negative 4, or it's 4, excuse me. And the distance here is 3. And so if you're familiar with some of the, the more commonly used triangles, this is a 3, 4, 5 triangle. So I'm not going to have to waste time calculating that. That's basically with the Pythagorean theorem. Now we have all our information. Now it's time to have some fun here. So we're going to first calculate sine 2 theta. So let's go ahead and take a look at that. So we got sine 2 theta. This is the first one that we were asked to calculate. Now to do that is going to be sine 2 theta. Let me go back to the equation. Sine 2 theta times 2 sine theta times cosine theta. All right, let's take a look at that. Sine 2 theta. Now, so here we got 2, then we got 3 over 5. Where did I get the 3 over 5? Well, remember, we have our SOHCAHTOA. That's what's happening here. And so for sine, since we're trying to figure out this angle right here, it's opposite over hypotenuse, so 3 over 5. That's how I was able to get this value right here, 3 over 5 inside the parentheses here. And then now for the cosine value, it's negative 4 over 5. How did I get that value? Again, if you go back here, you can see that we have the negative 4 right here because we're looking for the cosine adjacent over hypotenuse, so negative 4 over 5. That's where that came from. And so I plugged in my sine value, I plugged in my cosine value. Now it's just basic multiplication. So as you know, 3 times negative 4 is negative 12. 5 times 5 is 25. So we have negative 12 over 25. Multiply this by 2. And then we end up with the final answer of negative 24 over 25. So this is our exact double angle value right here, negative 24 over 25. So this is the answer for that first one. Let's move to the next one now. And now we're looking at cosine. So cosine, we're going to go ahead and calculate this. So cosine 2 theta, so when alpha and beta are basically the same value, is going to equal negative 4 over 5 squared. So again, if we go back here, we have our cosine value here squared and our sine value. Cosine is adjacent over hypotenuse. Sine is opposite over hypotenuse. So if you look at the unit circle, that's how we got that. Let's go back here. And then we're going to subtract 3 over 5 squared. So we just do some basic calculations here. So this squared is going to be 16 over 25 minus 9 over 25. Nothing amazing there. And then you simplify that and you get the value of 7 over 25. So this is our double angle. So if alpha and beta have to be the same value, it's going to be 7 over 25. That's kind of what's happening there. All right, let's do the last one. And that is going to be this time with tangent. Tangent is always a little bit trickier. And so we got tangent 2 theta equals the following. So we got 2 times the quantity of 3 over 4. And all this, that was all the numerator. And then the denominator is going to be 1 minus negative 3 over 4 and that's going to be squared. And say, now let's just go back to the formula real quick. So you know that for tangent, the exact value, you're going to do 2 times tangent, and tangent is going to be opposite over adjacent, and then in the bottom you had just tangent squared. So it's kind of the same thing twice. Yes. All right, so let's deal with the numerator first. So 2 minus, so this is going to be, let's see, minus 6 over 4. Yeah, that's correct. 6 over 4. And then, of course, you can reduce that. So we're just going to put 3 over 2. Make that life simple for us. 3 over 2. And then in the bottom, we have 1 minus, it looks like if you square that, you're going to have 9 over 16. That's what we get. So we got to simplify that even more. And so I'm going to change this from 1 to 16 over 16 just so I can do some subtraction. So 16 minus 9 is going to be 7 over 16 over negative 3 over 2. Now, if we have two fractions that we want to divide, you know that you take the second one or the denominator, you just flip it and you can multiply. So I'll just put this in a different color because I'm moving around. Negative 3 over 2. Multiply that by 16 over 7. And when you do that, you get 48, negative 48 over 14, and we can reduce that to negative 24 over 7, and that's our answer. So if we needed to have the exact same value for alpha and beta in the formula, this is the number we would use. And so these are the 3 different formulas for finding the exact value for a double angle. That's how we did this. So let me see if I can kind of go back and try to re-explain what we did and then wrap up the video. So in this video, we talked about how to find the exact formula for a double angle formula for an exact value. And so basically it's an extension of what we learned about for the sum and difference formulas for sine, cosine, and tangent. Where you're trying to, find a value that is not on the unit circle, if you will. Now, in the case of the double angle, what you are saying is that the alpha and the beta angles inside the formula are the same. So alpha equals beta equals theta, if you want. And so we can remove the alpha and the beta and just put a 2 there because we're just gonna double it. All right, and so essentially we just have 2 theta. Now, instead of putting 2 theta, I could have put 2a or 2 beta because remember they're all equal the same thing. That's kind of what's happening here. And so we just chose to use 2 theta, or we just chose to use theta. But it's all about doubling it. That's the main point here. So we started off first. We had our first value right here, and we were told some information about, okay, here's your first value. Here is the coordinates in. Now calculate these following angles here to make them a double angle. And so we took that information and we graphed it just for the visualization. We had 3 over 4, and so we know from prior experience with trigonometry that the tangent function is a ratio, just the sine of the cosine function, and so we were able to graph it. So we knew that it was 4 units to the left and 3 units up, and that's how we got it because we knew it had to be in quadrant 2. And we used our knowledge of SOHCAHTOA to try to figure out the different angles here, or different values here. Now, one other thing I need to mention is that since we knew that this was 4 and this was 3, we knew that the hypotenuse was 5. So we didn't actually calculate the hypotenuse in the video because we knew it was a 3, 4, 5 triangle, which is a very common triangle. Now, for the first one, we looked at sine, finding the sine double value, if you will. And we put in the following ratios, 3 over 5 and minus 4 over 5, because when you're doing this particular one, you have to follow this formula right here at the top. Sine over cosine, 2 sine theta times cosine theta. And we knew these values already, and then we calculated. We then repeated this process for cosine, again using the appropriate values here, which for cosine, we are multiplying cosine squared minus sine squared again, and then the final answer is down here at the bottom. And then last but not least, we completed the video by looking at tangent, which the formula is a little bit more complicated, but it just involves having the tangent of theta up here and tangent of theta down on the bottom, and you calculate the answer just using basic addition and subtraction, nothing too fancy there. And so that's how you do this. It's a lot of work. The practical application is sometimes not always apparent, but again, knowing how to rearrange these numbers in different situations can be very valuable when you start to deal with things that are, of course, much more complicated in mathematics. So, my name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.